Chapter 24, Theory Video 2. Now we are going to deal with the physical and chemical properties of the transition elements. Now we have dealt with what we have defined the transition elements. Now we are going to look at their physical and chemical properties. Because they are metals, they have all the properties typical to metals. They have high melting points, they have high densities, hard and rigid, so they are useful as construction materials. Good conductors of electricity and heat. They have variable oxidation states. That is a very important factor. Then they behave as catalysts. These are not common to other metals. Okay. Then they form complex ions and they form colored ions. So that is something that we have already discussed. Now, transition elements can exist in various oxidation states is a factor that we already established, and we saw that they have different colors. So if you when a compound of a transition element is treated with a suitable reagent, that element's oxidation state can be changed. So if there is a change in the oxidation state, then it involves a redox reaction. So that means here redox reaction means does not reduction in oxidation does not or may not involve oxygen all the time. Here what we talk about is transfer of electrons. If a species reduced, then oxidation state is reduced. When the oxidation state changes to a lower value, that is oil rig, you can remember that oil rig. Oil oxidation is loss of electrons, reduction is gain of electrons. So then when something is oxidized, it acts as a reducing agent. When something is reduced, it acts as a oxidizing agent. I hope you can remember that from O levels and the first half of this examination as well. Now if you take the half equation, Fe3 plus turning into Fe2 plus, 3 plus is turning into Fe3 plus by gaining an electron. So that is a reduction. Fe3 plus has reduced to Fe2 plus by gaining one electron. So Fe3 plus is going to be the oxidizing agent. So that means an electron acceptor. So for this reaction to happen, there should be another half equation giving off that electron that is needed. That means that should lose one or more electrons. So that means there should be a reducing agent, that means an electron donor. So we discussed how the electron potential is going to predict whether there is a possibility of a reaction to take place, right? So that can be used in this scenario as well to find out whether there is a possibility that something could lose electrons. Now when you take MnO4 minus, then it is a purple colored solution. When it gains electrons in the presence of hydrogen, it turns into pale pink Mn2 plus aqueous and water. So MnO4 minus is acting as an oxidizing agent and electron acceptor. So both of these half equations, Fe3 plus into Fe2 plus and MnO4 minus into accepting electrons and becoming Mn2 plus, they would have higher standard electrode potentials, positive higher standard electrode potentials. Now our question is, now they have Fe3 plus will have 0.77 and Mn2 plus would have 1.52. There is a clear difference between them. So here what we need to figure out is whether Fe3 plus ions can they oxidize Mn2 plus to MnO4 minus, or MnO4 minus can oxidize Fe2 plus into Fe3 plus. So that means what is going to be the most powerful oxidizing agent? Is it Fe3 plus or MnO4 minus ions. So now when there is a positive value to the half E standard values, we know that there is a tendency to proceed to the right hand side, that is for the forward reaction to take place. So then MnO4 minus, because it has a higher E standard value, we know that it is more likely to accept electrons and proceed the forward reaction, changing to Mn2 plus. That is more than the Fe3 plus accepting electrons to change into Fe2 plus. So as a result, MnO4 minus is going to be more powerful oxidizing agent than Fe3 plus. So as a result, MnO4 ions are going to be they are going to have the ability of oxidizing Fe2 plus into Fe3 plus. That means that the first equation can be reversed by the second equation. Now if you combine these two reactions together, then you have two half cells. Fe3 plus Fe2 plus half cell has changed the direction, because Fe2 plus is going to become Fe3 plus. So because Fe3 plus and Fe2 plus equation has only one electron, we have to multiply that by 5 to balance out the electrons, because the half equations need to balance out the electrons. So now we start off with the first equation is going to be 5 Fe2 plus aqueous becoming 5 Fe3 plus aqueous plus 5 electrons. Now E standard value is going to be negative 0.77 volts. Why? Because it is a reverse reaction. Then MnO4 minus is forward reaction. It will have 5 electrons involved in that. Then E standard value is positive 1.52. Then the overall reaction, we cancel out whatever is on either side. That means the electrons are going to be removed off. Then we have MnO4 minus MnO4 minus aqueous plus 5 Fe2 plus aqueous plus 8H plus aqueous becoming Mn2 plus aqueous, 5 Fe3 plus aqueous and 4H2O, and the E standard value overall is going to be plus 0.75 volts. That means the relatively large positive value of E standard tells us that the reaction is likely to proceed in the forward direction as we have suggested. I hope you understood that. Now let's write down a note for this first. Write down physical and chemical properties of the transition elements. Transition elements are metals. Therefore, they have physical properties that are typical of most metals. Number 1, high melting points. Number 2, high densities. Number 3, hard and rigid. Put a dash and write useful as construction materials. Number 4, good conductors of electricity and heat. Number 5, variable oxidation states. Number 6 are catalysts. Number 7, form complex ions. Number 8, form colored ions. Leave a line and write. Because transition elements exist in various oxidation states, when during a reaction a redox change takes place. Leave a line and write. When considered Fe3 plus conversion to Fe2 plus, underneath that write down the equation. Fe3 plus aqueous, that is pale yellow, plus electron E minus, put the arrow and write down Fe2 plus aqueous, which is pale green. Here Fe3 plus has been reduced to Fe2 plus by gaining one electron. Therefore, Fe3 plus is the oxidizing agent, the electron acceptor. For this reaction to take place, there should be a species to donate the electron. If we consider the equation MnO4 minus aqueous plus 8H plus aqueous plus 5E minus, giving Mn2 plus aqueous plus 4H2O liquid. So here manganate is purple in color, manganese ions are pale pink in color. Here manganate ions, MnO4 minus ion, is the oxidizing agent and is the electron acceptor. When their E standard values are taken, write down these two equations and their E standard values, please. It shows, after you write down, write this. It shows that manganate ions, MnO4 minus ions, will readily accept electrons when compared with Fe3 plus ions because of the difference in their E standard values. Therefore, we can deduce that manganate ions, MnO4 minus ions, are better oxidizing agents or more powerful oxidizing agents. This also suggests within brackets, right, the positive values of the E standard values suggest that there is a higher tendency for the half equations to proceed to the right hand side. However, because manganate MnO4 minus ions are better acceptors of electrons than Fe3 plus, it has the ability of oxidizing Fe2 plus ions to form Fe3 plus ions. Please write this change or the combination of two half equations and underneath that write the relatively large positive value of E standard proves that the reaction is likely to proceed in the forward direction. I hope you understood. If you have any questions, please ask.